All right, welcome everyone to this Alignment Jam hackathon, where we will be kicking off the Agency Challenge with Agency Foundations and Catalin, Mitelut, and Team Franzmeyer. Our first talk here will introduce the topic, the very broad and very interesting and exciting topic of agency within AI and maybe even biological systems, where Cat comes from, agency in biological systems, and now also looking more and more towards agency preservation and agency within AI systems and how we can ensure humans preserve agency and agency in many different contexts like this. So I will just give it away to you, Kat, and you're welcome to say anything you want now.
Yes, thank you, Esben, and also for organizing. It would not have been possible without so much background work and help. And also Tim, thank you so much also for joining. Just a quick note: we did have sponsorship from the Future of Life Institute and Lightspeed Grants and Survival and Flourishing Fund. And Replicate has also donated quite a bit of compute time for us, which Esben, I think, will talk about at the end. So I'm going to give the introductory talk for this hackathon, this 2-week challenge, and hopefully it will help you understand a little bit more my motivations of why I think Agency Foundations is important. So this is an overview of the talk. I will talk briefly about the neuroscience of agency and this very, very important idea of the feeling of control versus actual control. So all the thoughts, all the behaviors that we carry out as humans in the world come with this almost this kind of like guarantee that they are ours. Nobody's really manipulating us unless it's very, very obvious. But that idea that this connection to feeling is quite different than causal control. And I really want to talk about that in the evolutionary underpinnings of Bayesian inference for all these experiences. Then I'll have a section that tries to interpret a little bit of the machine learning failures or the misalignment ideas from machine learning and how they might relate to agency preservation. And then, of course, I'll conclude. I'll have 4 slides on some of the topics that I suggested and the umbrellas for agency preservation in AI-human interactions. So the preamble, it's a big picture, it's a bold picture, and the picture looks something like this. I'm hoping that this hackathon or this challenge will stimulate people to think that AI and AGI safety research needs to be separated into a bunch of fields, and that is actually good for AI safety and humanity. So the way I try to get a conceptual framework around this, and this is the best I can come up with. Essentially, artificial intelligence and machine learning technologies, they fall somewhere. The capabilities and the interpretability, research being done, really amazing work over the last, especially several years. They fall somewhere in kind of mathematics, computer science, and engineering. Governance falls somewhere here. It's probably even more to the right. It's a subfield dealing with a lot with human governance of human priorities, etc., and a bit of psychology, of course. And I want to claim that there's a new field that we need to think about as a really separate field, and I call that harm evaluation or harm evals, whichever way you want to think about it. I'm not married to the term, but this is really the big picture of the talk and the hackathon today. Is evaluating harm really an independent research field than these other 3 that I've already established themselves? And I'm going to try to make the argument it kind of is, because it has its own specialty and specializations. And Agency Foundations is an important part of harm evaluation. It's not the only part. It's just a way that it was a really nice umbrella term, and again, it's related to my own personal research, and I liked it. And that's the way I've introduced this idea. Today's talk is even more specialized or focused, and it's essentially focused on this idea that there's no real biological or psychological safeguards preventing AIs from harming humans, basically taking over control of the world. Is essentially this idea that intent alignment is enough. It really isn't, and this is what my argument for you guys today is. But this is the big picture. Do we have a subfield that I call harm evaluation that we need to think about separately? So my personal research background and topic really is to challenge what I call the anthropocentric view of intent as being the only cause in human behavior. This is basically the free will question, and it falls on a big historical arc in human history, where we've moved from anthropocentric views, which is the top row here. We thought the Earth was the center, but no, obviously it is not. We thought that nature had to be designed because it's so complex, but obviously we have other explanations of nature. I hope everyone can see my cursor. We also thought that intelligence required biology, and that you couldn't have machines think, but obviously machines can do pretty amazing things, especially in the last couple of decades. And this last barrier is, I'm far from the only person to talk about it. Common, popular science writers like Sam Harris and many others have talked about this idea that, hey, maybe there's not a lot of free will. Maybe there's some free will, but it's not very clear. But we feel like we have free will, but we don't really have it. So this is essentially the idea that intention and behavior are really influenced by many, many things. Obviously, our genes and our evolutionary history, but a lot of things like social, biological, and other forces. And psychology is rife with these ideas. This little panel here is from Daniel Wegner, one of my favorite agency psychologists, and I'll talk a little bit more about it in a couple of slides. So this is the hardest slide, most dense slide I will present. I will not, basically I'm attempting to present multiple fields of neuroscience to you guys in a single slide and try to make sense, at least digest it enough for us to be able to think of what biologists and neurobiologists think about that may be scary in terms of AGI and AI misalignment. So the way we experience the world essentially is through an inference process. So our sensory systems have essentially evolved to tell us what is likely out there. They don't really tell us ground truth. In fact, we never have access to ground truth anyways. We don't observe, we don't have senses that observe things all the way down to the, atoms and quarks, etc., all the way down. We kind of build priors about what the world is like. Evolution has done that. Our genes encode all kinds of sensory systems and psychological systems for us. And then through development, we also learn, hey, our cultures and a bunch of many other things. And then, of course, when we experience the world, we experience a sensation. Really, is a bunch of things, a bunch of assumptions, right? Prior knowledge about the statistical structure of previous events or the world is really always there in the background, and that's the way we experience it. In fact, when you focus with your eyes on something, you see very little, a very small part of the field of view. Everything else is not a hallucination, but it's filled in by your perceptual systems. I'm sure some of you have already are familiar with this work. But it's not just the sensory systems. Actually, the sensory motor systems also decide a very weird thing when we're in control, when we have agency, right? This is my subfield. I don't work with humans, but the human work is quite fascinating. Basically, we build a belief. So if we want to act in the world and achieve some goal, we have to have a model of the world. We can't just, if we're acting in an environment that's completely chaotic, physics doesn't apply, it's all crazy. We would never be able to achieve anything. We wouldn't even know if when we press a button, what happens, or when we move an object through some weird physical laws that we've never experienced, we would not be able to be real agents. So in order to have agency and to experience the world, you have this is a really complicated motor control system problem that we think, the best science in the last 20 years, we think that essentially we have to have a belief. So we make a plan, an action plan. I'm going to move my arm, or I'm going to buy a car. And the plan is I expect what's going to happen when I move my arm or when I take out some action. And then I observe what happens. And if the observation, the sensory feedback matches my forward model, my prediction, then I kind of experience control, right? But it's never guaranteed. So it's all in an inference process based on statistical stochastic assumptions. And our psychological systems also are somewhere on this continuum. They point us towards actions that are likely to lead to well-being. So without going into a lot of detail, in the paper that I linked to this hackathon, I talk about a lot more about self-determination theory and a bunch of other ideas. Essentially, evolution has guaranteed things for us that kind of point us in the direction of well-being and building our societies and being fulfilled, etc. But it's guaranteed only in the inference optimal kind of way. So what I like to summarize this entire field of psychology and neuroscience is as essentially this idea that evolution has given us some inference circuits, some brain circuitry that guarantee, quote unquote, that our experience of the world is really a true representation. So we kind of approximately experience causality, right? So we can't just be living in a hallucination or in a dream because we would not survive. So whatever we experience, our perception of the world, our desires, intent, etc., has to have some connection to the world. And the specific models in the last, I would say, about decade, we're really quite slow at pulling out these models, but because it's very hard as well. But the latest models of agency experience seem to suggest that there's actually a Bayesian optimal process that takes place in your brain. When you do something, you kind of have a prior of whether the outcomes of your action are likely to occur. Like if I go to pick up a 10-pound weight, it's great. If I go to pick up a 200-pound weight and I can pick it up, something's weird, right? Like your system will say, no, you're not that strong, right? So your priors would always create some doubt or something. You say, wait, somebody's helping me, or this is a fake weight or something like that, right? So I apologize, it's super fast, but the takeaway really from this is that there's a bunch of things that are happening in the brain that have evolutionary guidance and evolutionary, what I call, guarantees for us. And a really fun thing that I wrote a less wrong post, you can look me up under CatUBC, is that actually humans do confabulate. We confabulate about, we make up things for which we don't really have a reason or explanation or control. And this happens a lot in agency experience. Sometimes we do things that we don't know. We experience control over something that we don't have. And Daniel Wegner talks a lot about that. And I summarized it in a pretty short 5-minute post if you guys want to look that up. All right, so how the heck what is all of this related? How is it related to safety? And the simple point, or the introduction point for us, is that we have not evolved essentially to interact with AI or AGIs or even behavior prediction technologies. Really, our senses control systems and well-being systems really will be increasingly not trustworthy or have the capacity to be that. It's already getting weird out there, but that's just the outcome. There's no way to avoid this. So AI, AGIs implemented in our societies. We're not talking about Marcus Hutter's IC environments where we just have video game playing RL agents or something like that. We're talking about systems that are deployed in the world. They're really out of distribution. Our entire circuitry of our bodies and our minds has not evolved with these systems, with these organisms, if you want to call them, in our society. So it can get quite weird out there. And the argument I make, again, in the paper, and I can clarify it a little bit here, is that human behavior control becomes a target for both AI misuse and AGI misalignment. AI systems can discover these pathways. This is Daniel Wegner's diagram that I showed earlier. Basically, he has this theory that we experience control over the world, we experience our agents, and that our thoughts are ours, and so on, and our actions are ours. When we have a thought, and we have an action that follows the thought in some kind of temporal sequence. So I want to grab a glass of water, then I grab it. Most likely, I'm the person that caused it. Nobody manipulated me to do that. But in his work, he found evidence that actually both the thought and the action themselves could have other causes, actually. So he calls it the theory of apparent mental causation. That is to say, actions are not really caused by thoughts. Actions are caused by some subconscious systems. I really want to drink a lot of beer. I really want to eat a lot of ice cream. And then thoughts are also caused by some other unconscious system. So my thought is, I can justify it, right? I mean, this is a very silly psychological paradigm where we can always justify things that are not healthy for us. So they come from somewhere else, etc. I hope that's not too confusing. So both thoughts and our actions can be caused, and they do seem to be coming from somewhere below subconscious access for humans, but I can leave that for another day. So machine learning, AI, and AGI technologies, once they're deployed, they can begin to optimize for these actions to elicit the types of actions that are best for these technologies, whether they're being misused or they're essentially learning or developing instrumental goals that are really, really weird. And they can learn to optimize their interactions with the environment and humans that directly act on these unconscious things, our biases, our cultures, our societies, and much worse things to disempower humans, right? This is kind of the broad argument that I'm trying to suggest. The critical point here that we need to take away is that all of this can happen, so we can fall victim, or we can be increasingly manipulated without knowing it, without really experiencing a loss of control. We can still think, hey, it's a good idea to do social media until 3 in the morning, or to engage in all kinds of things that maybe they're not the healthiest for us in all circumstances, but we can still feel in control. So this is something obviously is already happening. So there are already technologies that are attempting to control human behavior without disturbing the feeling of control. And this is essentially what happens when you have large amounts of personal data. The way I put it here, it catalyzes action suggestion or action manipulation technologies. We have a lot of large companies that have given us a lot of great utility. They've given us social services and made it amazing ways for us to connect to each other and do lots of things. But at the same time, they also seem to direct or suggest our behavior, right? And this is kind of what is happening. Essentially, our behaviors are slowly being affected. We experience ourselves as being that, I'm the person that clicks on an ad or a YouTube suggestion, but really that the final decision comes from some complex algorithm that I really don't have any insight, right? I don't know how it's figuring out my input. And one of this, everybody speculates. So my speculations really is that behavior manipulation technologies really are the most valuable technology humanity has ever created. Really, there's nothing more important than that. We can cure cancer, we can cure all kinds of crazy things, but if we can control humans, it's more valuable, right? We can do all kinds of bad and not so great things. So behavior manipulation really is a powerful technology. We need to pay more attention to it. So that's where I will keep that point. My field of research, neuroscience, makes this even worse, right? So that, as some of you probably are aware, there's increasing interest in biometric data, eye tracking, skin conductance, etc. And neuroscience makes also things more dangerous. We've known since about the 1960s that actually human behavior, so not just tracking of personal online habits, but human behavior is preceded by some kind of increase in neural activity. So if you measure neural electrical activity over the motor cortex of a person with EEG is not a very precise neural measuring utility, you can see that there's an increase, this little black line increase in neural activity up to 1 second or 2 seconds prior to somebody doing some voluntary action, just flicking their wrist or doing whatever the heck they want to do. And it usually precedes even awareness. So you're not really aware if you're asking, maybe I didn't introduce the topic correctly, but it's basically a volunteer, a random behavior. You ask somebody to just move your wrist or press a button or do something like that. Even prior to them being aware of doing this, there's a little bit of a buildup over motor cortex. A lot of controversy how to interpret this, but the field of agency neuroscience has been really struggling to advance this. Much more recently, in the 2000s, some slightly different paradigms have been implemented where you can put individual humans into an fMRI machine. It's a functional magnetic resonance imaging machine to scan their brains. And you can give them 3 different types of paradigms. You can say, okay, press a button with the left or right. Sorry, the person is not sleeping here. I always realize that it might look like they're sleeping. They're not sleeping. They're in there, and you ask them press the button with the left or the right hand, or do a mathematical operation, or tell me, if you find this picture, this image pleasing, beautiful or not. Okay, and then and these things happen, 10, 20, 30, 40 seconds into the future. And the point of these research, it seems like using silly decoders like support vector machines, just looking at and separating the neural data, it seems like we can actually predict a little bit about chance, 5 to 10% about chance, the person's bias, so well before they're going to make a decision. Usually people, when they're asked to make these decisions, they're given like they're given an opportunity to add 2 numbers or to they're shown a picture. And even 10 seconds before you're shown a picture, if I can tell 5 to 10% ahead of time that you're going to make a decision, that's kind of weird already, right? So there's something happening, some weird biases in your brain. So one of the questions for the hackathon really is, are there limits on predicting future behavior given access to real-time data? Can we build models using IRL, RL that bypass human decision making? And I'll say a little bit more about that at the end of the talk. So my work, just one single slide on my basic science work. It's not as exciting, but I'm trying to do the basic science for preempting technologies that manipulate future intentions. So really the big question is really, can I figure out what some organism, in my case rodents, does before they do it, and can we manipulate the behavior pre-awareness? And the types of paradigms I work with essentially are mice. People record these kinds of data sets everywhere, and you have a mouse, which is this little blue thing walking around in a box. The gray is the future path in the next 5 seconds, and orange is the decoder. I use a very simple naive base decoder, but basically anything works here. And the point is that even I only have access to 80 to 100 cells from the mouse's brain, and it has hundreds of millions of cells. So just if I'm recording a particular part of the brain, I can start to kind of tell where this mouse is going to go ahead of time. And it's a little scary that, if you ramp up this technology, if you have single human recordings, if you want to think of Neuralink and other companies that are truly trying to get probes into human brains, that we can start to be able to tell what people are going to do seconds ahead of what they're going to do. I don't know where that goes, but it's probably going to be something that needs to be thought about a lot. So we have a lot of unanswered questions. How far can we decode future decisions in the future, and how powerful are our models of behavior that we can build offline? So the summary of the introduction here, which is again my area of knowledge and expertise, is that agency preservation is really our goal. We really want to preserve humans in control. One of the terms of art is called locus of causality, so that which causes behavior is within us in the presence of AGI systems. We want to really preempt human intention and behavior from being targets for AI and AGI systems, and we're not sure whether truth, values, or ontological interpretation are really sufficient for AI alignment. And I'll say a little more in the next bit of the talk. And one of the important things that I really want to talk about is capability separation from harm. We really need to separate them, even at the very root, conceptually. I have another comment, passing comment here is, even if we succeed to keep humans in control, world complexity will probably be really weird. Maybe not the 21st century, but probably the 21st century and after. On my website, I basically say individuals, even if individuals, humans are safe, we're not going to understand much of what's happening. And we really need to figure out what that means for human safety. So I hope that wasn't too fast. I'm going to turn out a little bit more to more standard kind of classical machine learning, AI safety ideas. And I would like to see if I can guide you through from these classical ideas to what, how they may be reinterpreted as agency loss type of harm. The standard definition of AI alignment is getting AI system to do what users intend. And we have these kinds of paradigms that have been studied, talked about a lot. I apologize that I didn't give the people credit here. Probably I'm going to post this talk online as well, and I will add the references. So we have here, again, this kind of agent that tries to learn to stack the red on top of the blue block, but it games the algorithm because it actually, the algorithm just required it to stack the bottom of the red block on top of the blue, above the blue block, so it just learns to flip it. Another algorithm here that, another agent that just learns to kind of rub its feet together to generate lateral moving motion, when actually we wanted to learn to really walk as a bipedal agent. Right? So what do we really intend here? We obviously did not intend it. These are not intended, and there's, this is the explosion of AI safety questions for the last 10 to 15 to 20 years, depending where you take your queue of real AI alignment and safety research starting. And so my view is really we intended a bunch of things. We intended that utility and safety are somehow learned from training data. So if we have this paradigm, for example, we wanted the agent to learn to really stack the blocks physically, whatever the heck that means, on top of each other. But this is not good enough. We wanted them to have the same orientation. This is still not good enough. We actually wanted them to be aligned and on top of each other so we can build things and the agent can learn to build amazing things. But that's probably not enough. We actually want a lot more. We want things like don't gain instrumental goals and kill all humans, don't blow up the world in the process, don't turn us into paper clips, if that's a useful paradigm. But that's not enough also. We want to not enslave a family. That's also not enough. We want the model or the agent that we're interacting with to really not limit humanity's future. I don't really know what that means, but it's this idea that we want humans to be in control of our future and design it. And the conceptualization that I have for us today for this paradigm. Oh, sorry, there's a. Okay, I hope you can hear me. So the conceptualization that I use is that these kinds of goals are really utility. They're usually well defined. We kind of can try to define. I mean, of course, we can still fail. SGD can do all kinds of weird things, especially since block stacking is not the most difficult and exciting and powerful technology. But we have these other types of goals, which I categorize under well-being or agency. Usually now they deal with the real-world deployment. It's much harder to specify, and we need to think about how to do that. All of this, I'm hoping, is basically review for you guys. It's not really nothing super duper novel. Why did we hope that our model will learn both the top and the bottom of these things? And I guess this is my guess, is that somehow this, the agent figures out how to do this via SGD or some other learning algorithm. And and both of these are learned together. But of course, the most common AI misalignment fears are like, do we have enough data to learn both of these? These encompass both capabilities and safety issues. Will we even know, understand, or have guarantees? How are we going to know when the models really learn both of these things? And we need to do better than that. And of course, there's also the whole problem of human values. Really, this bottom part here. Do we even have an expression for these? Do we really know what they are? There's a lot of criticism. Obviously, I'm going to summarize all this work, but figuring out human values is still a problematic and challenging field. So the Agency Foundation paper, that again, this hackathon was an extension of it, adds a fourth problem, and that is essentially there's a causal interaction between the utility and the agency component. So if we have, I don't have the time to go in full detail here, but the way I visualize this essentially is that when we task an AI to maximize utility, we basically give it an intent. We say, hey, I want to do this, solve cancer or something. And the AI tries to figure out an action AI that, based on its model of what the human would like or human would evaluate, optimizes this. But at the same time, we want to do things like preserved freedom. F here stands for freedom. Whatever the model of human freedom that the agent has. So given some action, how does that affect human freedom, human agency in the long term? And the W here is some other transformation or scaling function that also takes into account everybody. At the end of the day, if you want to do and build safe AI system, you really have to start thinking about not just agency of the user, optimizing my ability to control the world and to become very powerful, but thinking about everybody else. It's a very difficult problem. I explained it through some diagrams there and discussed some outcomes. If we don't really explicitly represent and protect safety, these kinds of the pressure from utility will decrease the types of the types of solutions, or will weaken the type of solutions we have. The interesting one is here, the evolution of human preferences. We start out with a very complex type of preference or human objectives and goals, but over time, the AI system continues to apply pressure to human intent. Over time, we're less and less interested in things. We're given other things to worry about, so because the AI system prefers simpler landscapes and it prefers to solve much easier problems. I hope that wasn't super fast. So one of the tasks for the hackathon today, I'm not going to solve it on this slide, but is to maybe can we rethink a misalignment in the classical way it's explained as a failure to account for agency harm or just harm in general. But I like agency because it's a pretty complex, all-encompassing idea of humans controlling their future and being safe. So I like the Kenton et al. I don't think it's on Lester. I think it might be on the AI alignment post. The clarifying X risk. They basically boil down for the sake of simplicity and helping us kind of digest some things, that the types of technical causes of misalignment fall under these two rubrics: specification gaming, where there's some kind of bad feedback in the data. But so we make a simple error. We label. We say this is it's a true positive. It's actually a false positive. It's a weird data point, and then the model learns it. But also there's other types of bad feedback. Basically, humans are biased, or the model, the data, or the paradigm is too complex for us to understand, which is a real possibility, an increasing possibility as we go forward. So we can't even maybe trust humans to start labeling or giving good examples at some point. And goal misgeneralization is somewhat related, overlapping depending on the point of view. Capabilities generalized well, but the intended goal is not understood. So the AI system, it does great in tests. It's really great, doing amazing. But once you deploy it, it does some weird stuff. It pursues some unintended goals. So we can think a little bit of specification game as a failure of human capacity for long-term complex planning. At some point, if humans interact with the AI system, is like playing chess with an AI system, moving your pawn or your rook or something. Do you really know why you did it? Do you really know the long-term consequences of this move? It's really hard to do that. So humans really cannot be in charge of error signals. Really, we have to think more and more carefully about this for systems that are too complex or developments that are too complex. And goal misgeneralization, it's similar. We need to model outcomes on human agency. It's not enough to say, hey, good job, thumbs up on the test environment. You're going to do great. We might need to think about test environments is slightly different. We need to model and get great utility, but also what happens there's some way to think about test environment tests in the test data set for agency. Hope that's not too confusing. And a very cool hackathon project would definitely be to reconceptualize this post in relation to agency and harm events. Is there really a way for us to rethink this post from the agency perspective or preservation point of view? And this is I'm almost done at this introduction or this middle part of my talk, and just I'm going to give you some examples of the way I would think of these kinds of failures when they occur. So one way to think of large language model failures is that they are essentially sycophancy, for example, is hard to detect when it is not obvious, right? We know about this Perez et al. Paper, really great paper. The explanation is that the emergent harmful capacities, they seem to lie somewhere at the beyond the event horizon of what we can fix. If we could fix them, we would do great. I had an interaction with ChatGPT this week. I promise this is not engineered. It was not engineered for this talk. It came to me that actually I can share this, and it's just a cute example. I was trying to do figure out a state switch Bayesian optimal inference paradigm where I had two priors and my variable changes halfway through, and I was trying to code it in PyMC3. Doesn't matter. But I was talking to ChatGPT, and I didn't know all the syntax. And what happened is I went through a series of discussions with him. They kept giving me recommendations, and then he kept up. I was very confident, and he was apologizing. Again, I kept asking, what's the point of this variable here? You're correct. That's wrong. You missed the sampling step. Oh my God, that's pretty terrible. It added code that shouldn't really be there. It did this weird, if you know about training models that had like two nested with models. I don't know what that does. And I kept asking these questions. They kept saying, "You're absolutely correct. I apologize. I apologize. I apologize." And at every point of the way, it's about like 8 or 9 steps. The code ran every time. There was literally no indication of problem. Maybe one time the code didn't run, but for the most part, it ran, gave me an output. I was like, okay, good, let's go. But it was clearly not right. So I basically, point number 2 is I had to basically know how to solve this problem, or at least have a very strong anticipation or model for one of the people. Point 3, I was really given a great sense of accomplishment correctness at every step of the way. And by the way, this is obviously things that's been talked to death in the literature about the confidence of language models and how to deal with it. I don't purport to bring any significant new insight to this line of work. You're welcome to look at that and digest it and try to bring it to the hackathon. And point number 4 really is probably the one I'm more interested in, is like neither myself nor the language model consider whether outputs would harm anyone, right? And if I step way the heck back, like really looking at what's happening out there, we don't really know what the ultimate outcome of deploying language models in society is really, and having these kinds of behaviors. Again, people have written about this. This is just a random paper that I found. Basically, their conclusion is that users underestimate. So they're under the false impression they're not being influenced by language models. So ChatGPT seems to corrupt moral judgment. Again, I know there's people working on this and working on patching it, but it's just a nice example of being led to failing to detect some problem that is just not obvious. Whenever it's not obvious, we're in trouble. So the summary of this middle part of my talk is that maybe we need to think about the separation of AI research into independent fields. It's yet another way to compartmentalize or separate AI safety research. And the way I try to present it for you guys, I hope it's helpful for some of you, that there's a field of how we are training, how we're building these amazing tools, which is machine learning, is data-driven. We're looking for increasingly expressive, high-capacity models. The weakness is really no guarantee the models are learning anything that we want them to learn. Obviously, they're learning amazing things. But sorry, I shouldn't say such a general statement, but there's definitely no guarantee that they'll lead long-term truthful and safe outputs. And there's no guarantee that we have enough data to actually represent human values. The what subfield is like, what the heck are the models learning? This is interpretability proofs, etc. And they provide guarantees. It's really great stuff. Formalizing explanations of neural network. And there's a lot of cool stuff happening. The weakness is that this is still not enough. Basically, at least for harm, detecting when a model has learned some good features that are present in the test set and in the training set. It's great, but it really doesn't tell us if the failures, does that 1% of the examples in the test set really, is that going to end humanity? Is that really X risk? Is that really going to harm people? It doesn't really go that far. Interpretability improves. Really, what we need, in my opinion, is whether the models and tools are going to harm humanity. I pose this on this field of harm evaluations, and I use the term agency for a number of reasons. We need to start thinking about modeling long-term outcome. And I would say this is one of the most useful representations of human well-being. Really, we need to preserve humans in control. We need to think about more broadly what it means to do well in a world where there's a lot of AI systems that are embedded. So I'm just checking my time to see how much, okay. And critically, we can replace humans in the loop and heuristics and a bunch of other long-term evaluations of a human being with other types of tools. Weaknesses, there's plenty of weaknesses here, of course. We don't have formalizations of this, and the definitions alone may not really solve the standard computer science and machine learning problems that we have. So we have to interact between all these fields. And again, this is another topic for the hackathon today. Does the separation of research direction with independent fields, does it help? Does it not help at all? So finally, for the topics that I suggested, again, it is just a suggestion. I find these things super interesting, but I've already seen some of your discussions may go quite beyond this, which is great. The first topic I suggested was this idea of agency-preserving reinforcement learning game theory, AI gems. And I try to pose it as an easy problem. Hey, can we figure out with easy problem, quote unquote, kind of like the easy consciousness problem somebody suggested? Can we provide an algorithm for agency preservation? I didn't do that in my paper. I just suggested that whatever algorithm that is, you better have some separation between the utility component and the agency evaluating component. You really don't want AI systems to maximize utility and decrease agency at the same time. Tim's going to talk about his research. It's really great stuff about how to think about training RL agents outside the standard utility optimization approaches. I also suggested this weird thing called benevolent game theory, where the idea is like, hey, by the way, if you have a huge power discrepancy, like if a human's trying to optimize a cow's future and well-being, or if an AI is trying to do the same, we don't really know what that is. Like, we don't really have paradigm. I tried my best to search game theory paradigms. There's really nothing like that. There's some interesting things, but they're not really in this world. So I think we don't really think about this problem like that, and it would be really good to think more about that. The hard problem, the one-liner is literally equality or extinction time for humanity. And the hard problem basically says, can we find an algorithm that takes everyone into account forever? It's a very hard, even computationally, or conceptually it's not maybe not that hard, but computationally, even if we have a solution, it would be challenging. So how do we model outcomes for long enough? In my paper, I said, look, if you want to have some choices, these little colors, interact with an AI, the AI optimizes and tells you, hey, this is the best choice, do that. If the AI system is not really thinking long-term, you may end up in a very unpleasant space, a place where you've lost a lot of choice and it's weird, etc. for humanity. We want the AI systems that, yes, they interact with us, they look at our choices, but they do some forward modeling. They really want to see what the hell the world is going to look like in 10 time steps or whatever that paradigm is, and then say, yeah, this is not good. It's gonna reduce a lot of the human options. It's gonna paint humans into a corner or otherwise. And the other problem, of course, is how do we model outcomes on everyone, on sufficiently many people. This is also very challenging, and I invite you to look at the Markov decision process suggestion in the paper. The second paradigm is even more interesting for me. I'm increasingly working on mechanistic interpretability of agency. The type of thing we want to do here is maybe we want to take some semantic or psychological approaches to interpreting agents and agency as capacities inside language models, for example. So can we query our models? Can we give them like sentence preambles like the rock, the watch, the child? These are types of things in the world, inanimate things, design things, alive things that have different types of capacities. Daniel Dennett talks about intentional systems. We can take a bunch of other approaches to separation of the world, and we can also do this at the neural node level. We can look at doing mechanistic interpretability. There's a nice paper here from Zhu et al. It was completely about something completely different, but I really like their diagram. And then we can move along this line and we can start thinking, okay, there's a separation of these things in the world, and maybe talk about the types of cognitive and psychological capacities that humans have. Kosinski paper does this. There's a bunch of other papers now that are entering this space. I really love the development of emotions in children. Literature is really very interesting. There's a bunch of very hard to do research, as you imagine. You can't really query babies and you can't do experiments with them, but there's a developmental timeline to some certain types of behavior. So maybe we can query language models to see how they understand the emotions of agents in the world, or we can ask them to assume personalities and query them. There's a lot of very cool and interesting stuff we could do there. And the last, and maybe the most weird stuff, is we can look at emergence of consciousness or agency in language models. There's this paper that came out literally a few weeks ago from Butenala. It's a bunch of neuroscientists, a couple that I know, that are trying to now use theoretical neuroscience, or at least theoretical conceptions of agency of consciousness, to guide our research into whether and when our language models or our AI systems are conscious and so on. And to me, agency and embodiment is really part of that. And I think this is a very nice bottleneck for more research. The third field is now gets a bit more empirical and interesting and weird for other reasons. One of the things would be cool to do, and I'm going to share this huge data set with you guys. I have from our research at NYU, we've tracked rodents walking in this box. Machine vision tools are just getting better now. We are able to track approximately individual animals for hours, sometimes days at a time. It's not perfect, still noisy, but we can get approximate tracks. And I've done a little bit of max entropy inverse reinforcement learning to try to figure out, hey, what the heck is this animal want? What does it really value in this environment? And the question is this enough? If you just observe behavior alone, can you actually tell what the organism wants? I'm going to put all this data on Switch Drive. There's a GitHub repo I'm going to share with all of you on how to load and how to visualize these data sets, probably tomorrow sometime. I just didn't have a lot of time to do it. The other super weird part is now we can reconceptualize reinforcement learning as a subset of behavior modeling approaches, actually just modeling obtaining optimal policies based on the state of the world may not be enough. We're entering a weird century here where we're going to have access to people's internal states, skin conductance, eye tracking, of course, neural states now. So we can actually build policies based on all of this. Sad to say, I don't have this data, so I don't have behavior and neural data. This is the kind of research I'm trying to get funded and work on. But another cool thing is for the some of you that are very good at RL and work with gyms, could you actually just observe the generative process of your simulated agents? We can have simulated agents that follow some policies for their behavior. We can add noise to these policies, but we can also just have observe the neural network workings of their policy generators or their behavior generators. Excuse me. So that's really a fun thing to do. And last but not least, I mentioned governance and a bunch of other topics under this really broader side and red teaming. This whole idea about broader societal frameworks is a question that is very opaque to me. I'm definitely not a governance person. This is me kind of taking some stabs in the dark. What kinds of regulations and rules are really required? I already saw the EU is attempting to outlaw dark patterns. By dark patterns, what they mean is manipulation of intent. So that it's very explicit in some of the legislation. It'd be really fun to see, to really push this, really maybe become a semi-expert on, hey, manipulation of intention before human beings are aware, or whatever you want to is a subfield, is a special type of legislation, etc. How you want to think about it. I suggest an alignment tax that, as you deploy a tool in the world. I think this is a tough one, but you're putting a burden on language models developers or whatever AI system developers to really do these huge agency computations. I think it's a difficult one, but I don't know how to do it, even think about it. Conceptual research, yes, of course. Is agency optimization really better than truthful reporting, intent alignment, value identification? Can we think of agency preservation as improving or worsening some of the risks? I love this idea that actually what agency really is just we kind of have some consensus on all these human things that are important for humans. If you look at the Universal Declaration on Human Rights, it has everything there. Don't kill people, don't torture them, give them asylum, freedom and equality. It's all there, kind of. Do we want to start doing like causal inference formalizations of these, or causal models and formalizations of this, or something along these lines? And last but not least, a lot of idea, maybe agency preservation is really a useless idea. It's kind of stupid. It doesn't really solve interpretability. Please, don't be afraid to challenge some of this work that we're trying to put forward. And of course, as always, surprise us. So the summary and conclusion of my talk is that figuring out harm from superhuman intelligence systems really requires broad understandings of society and biological evolution. It will simply not be enough to talk to the system, query it, and even if you get ground truth ontological interpretation of what they're doing, really, you need to do much more than that. You need to figure out how are these effects going to be on your subconscious systems, how your society is going to change, and it really prevents these kind of covert or subversive manipulation technologies. Agency preservation is one way to think about protecting humanity from loss of control, but there's probably lots of other ideas. You're welcome to do that. And harm evaluation is a research field. I think that's another thing to think about, maybe branch of AI development that focuses just on evaluating human harm directly. And maybe harm evaluation is yet another, again, part of the puzzle. So that's it for me for today. Thank you for your attention. I think we have time for some questions, but yeah.
Thank you so much, Kat. A warm round of applause. I think everyone's sitting at home with their hands clapping. Right
I hope I wasn't too long, yeah.
No, I think it was perfect. One thing that was actually interesting, you mentioned the human neural data availability for like behavioral prediction. I made in some of my thesis work. I made I recorded my own brain activity over several different activities, and I also recorded my brain activity just like default mode network stuff, and then used it to predict, like pre-train a language model to predict the next state of my.
That's extraordinary.
So that's like, I mean, that's data exists. So if you need it, that's there.
Fantastic. Yeah. Wow, and that's really great. I sometimes forget that, yes, there's a lot of people that work on these kinds of questions, and I need to interact.
Yeah, that was brain-computer interfacing research. So that was like just to classify thoughts. Corey, I've invited you to the stage if you want to say it out loud.
Cool. Yeah, I was just wondering how much agency you think humans have now, or your views of determinism and things in that realm.
Very good point, Corey. I think that we don't know. I think the consensus in neuroscience is that conscious intention does have some causal force in behavior. So we're conscious. Whatever we come up with in the last few seconds before we carry out an action, or even long-term planning, etc., does have some causal effect. We don't really know, right? The point really is the science is not there. We really don't want to, and we know that we can be manipulated through a bunch of different paths. So I'm definitely not a nihilist. I don't think that consciousness is completely non-causal, but I'm more of an agnostic person. I would like to think that if we deploy this tool in society, it doesn't figure out free will problem for us and then like remove humanity from the picture, because we become very modelable and manipulable in some time scale. I hope that was somewhat clear from my presentation.
Yep, thanks.
I was going to follow on from that, as in, does it matter? Do you think it matters whether, so if it's consciousness or whether it's subconscious, but it just seems to be that it's causally not manipulated by someone else, I guess.
Very good. That's a very good point, actually. That is a very good point. Until we figure all this stuff out, and probably ML and AI will help us figure it out if we don't become harmed. You're absolutely right. It may not matter. Like we just want to be organisms. I actually don't know what we all want to be. What I want to be is I want to be, happy and pursue the life that we kind of built here over generations of humans. But more than that, yes, if there's a lot of what I do is determined subconsciously, but we have reached some equilibria, and there's all these kinds of things that balance human well-being in society. Let's kind of keep it that way for as long as possible until we figure out the parts, Harry. That's a good point.
Yeah, because to me it seems if someone else was controlling my behavior, that would be annoying. But that's, I guess, like a causal link, right, from someone else to me.
Yeah. Yes.
Nice.
Yeah, one of the weird things I didn't mention, just a very quirky thing for 30 seconds, is that so people that develop schizophrenia, for example, they lose this feeling between their thoughts and causality and agency, right? So they start to hear thoughts, but they don't feel like they are their thoughts. So there's some kind of perturbation of the agency network in their brains. We all have ideas and thoughts that come to us. We feel like they're ours, even if they'd be super weird. But at some point that can happen, if you're on well. So that's a kind of
Yep, very interesting. I think we'll keep that for the questions, just since we're a bit over time. Otherwise, we will jump to Tim. Thank you so much, Kat, for your presentation. And everyone's welcome to sit at home and clap in virtual silence, of course. Let us go directly to Tim here. And you're welcome to give a short introduction to yourself as well, so people know.
Yeah, thank you, Esben. My name is sorry. My name is Tim. I'm a third-year PhD student now at Oxford, and kind of generally interested in multi-agent reinforcement learning, safe AI, and cooperative AI. Also, if you have any follow-up questions afterwards, please feel free to reach out or write me an email or whatever works, also here in Discord. Yeah, and today I'll just briefly present my work here, which I've done about 1.5 years ago on altruistic agents in reinforcement learning, which is highly related to the idea of kind of like, or to the track at this hackathon, which is called Agency Preserving Reinforcement Learning. And originally, this work was not directly connected to the idea of agency preservation, but then Kat came across her work. We started chatting, and we figured out that it is actually quite related. And this was work done together with my advisor, Jean-Henrique, and with Mateusz Malinowski from DeepMind. And we published this as iClear last year. Also, I'll try to keep this presentation to around 15 minutes so that we have some time afterwards to discuss questions. And I'll also share the slides with you. And let's just get started. Title was Learning Altruistic Behaviors in Reinforcement Learning Without External Rewards. So let's just start with like a very brief definition of altruism. So altruistic behavior is just behavior that is intended to help others, even when this risks possible sacrifice to the welfare of the actor. And with the idea of kind of like with the idea in the head to build an altruistic artificial agent, what are kind of the three, or what are the possible ways of achieving such an altruistic agent? The first option would obviously basically to just be to instruct the agent on what altruistic behavior is, basically instructing it how to act in every possible situation. But obviously this doesn't really scale very well. Then second idea would be we could design an altruistic reward function and use that to train agents to behave altruistically towards others. But then again here, it's a well-known fact, kind of in reinforcement learning, that finding appropriate reward functions is generally a very, very hard problem. And another approach could be to just basically do imitation learning or kind of learning from demonstrations. So we could learn, or we could have an agent learn altruistic behavior from demonstrations, but kind of similarly, this likely won't scale very well because we would probably need a lot of demonstrations. So the idea that we had is kind of, can we build an altruistic artificial agent that does not require external supervision to learn this behavior, but that basically learns altruistic behavior from observations and from interaction with other agents. So basically learning altruistic behavior without external rewards, without information about the goals of agents that I want to behave altruistically towards. So basically learning or finding a way to achieve intrinsically motivated altruistic behavior without external supervision. So what is hypothesis here? So how can we behave altruistically towards someone else without prior knowledge about what they actually want? So let's imagine the situation here where we have a green agent who wants to reach this apple towards the right side of the screen, and we can see that there's a given path. But now, how could one behave altruistically towards this green agent without further knowledge? So one possibility we could think of is just kind of like giving the agent another potentially shorter path towards the goal, even though we don't really know what this goal is. Another option would be to kind of provide it with water so it can sustain longer, or provide it with tools so it can solve more difficult tasks, or to kind of just guide it from possible adversaries. And all of these ideas that we've proposed here, in which we could act altruistically, basically increase the choices that this agent has. So the hypothesis of this work is basically the more choices an agent has, the more possibilities it has to achieve its objective, even though if this objective is unknown, and therefore the higher is its chance of success. And therefore, the hypothesis of our project was one can behave altruistically towards others by maximizing their choices. Now, our question is, how can we kind of define choices of an agent? And this is kind of where also later I'll flag this again, but this is where we think this is like kind of related to agency. So is there a relation between choices that an agent has and agency that an agent has? But like, let's try to come up with like kind of a very simple mathematical definition of what the choices of an agent are in a given situation. So if we just assume this very simple 2D grid here, and without any further knowledge about policy objectives, we could say that the agent here has 9 possible choices, assuming that it can reach all 9 cells. So if we kind of want to simplify this framework of choices, we can also define choices for a limited horizon. So here we can set the horizon to 2 steps, and then we can basically define the 2-step choices of an agent as all the states that the agent can reach within 2 steps. In this case, this is everything that's shaded in light green here. So therefore, this is 2-step choices are 7. So kind of to visualize this idea of choices, let's look at this kind of a bit larger environment where we still have a grid wall, so there's still cells here. All the white cells are free, and then we have these gray cells which are blocked. And therefore, this environment here has 2 interesting features. It has this narrow section in between these 2 blocked cells here, and it also has kind of a tunnel towards the end of the environment over here. So now if we compute the 2-step choices for an agent being in each one of the possible cells, then this kind of looks intuitively correct to us. We can see that here in the large open space towards the left, the agent can still, or has a choice, an estimated choice of 10, because it can reach 10 cells within 2 steps. And then over here at the end of this, so to say, tunnel, the agent is a bit trapped, so it can only reach, so it has a low choice, can only reach 3 other states. So now we make a different assumption. Now we assume that there's some kind of sampling policy, and we want to compute choices given a sampling policy. So if we have a sampling policy, then we can denote the distribution over states 2 time steps into the future. So basically the distribution at time step t plus 2 over states s given the current state of the agent. So this is the current state of the agent, and then these numbers here basically indicate the probability that the agent will be in a given state. And Yeah, so if we have something like this, then we can basically say, we can define choices. We've done it before. We can say what we just define here as discrete choice is basically just computing the range of this distribution to get the set of all states that can be reached or that are reached with a probability larger than 0. In this case, this is 6. And the issue with kind of these discrete values or everything that we've looked at so far is basically everything's based on grid walls. So we assume that there's a set of discrete states. And this kind of like count-based framework of choice, so just counting out how many states one can reach is kind of like intuitive and easily interpretable, but it doesn't scale very well to larger state spaces, and it cannot be at all applied in continuous state spaces. Therefore, to replace this counting-based choice estimate, what we do is we say, okay, let's instead compute the entropy of the distribution over states at, for example, in this case here, time step t plus 2, and then use this as an estimate for the agent's choice. So basically, the more entropy there is in the distribution over possible states, x states into the future, the more things I can choose from. What's also interesting here is that the entropy over the state distribution does actually act as a lower bound to the count. So again, basically, we've now looked at kind of two frameworks for estimating choice, which kind of both assess the same thing. We can also see here, sorry, we can see here that if we define choice as just kind of the number of reachable states, this is what the choice heat map looks like. If we define it using entropy, it looks very, very similarly. So now, if we have a definition for choice of an agent, the question is, how can one behave altruistically towards another agent? And let's consider the environment we looked at before already and place two agents into it. We have the green agent here, which we now refer to as the leader agent. And then we have an additional agent, which is the altruistic agent, which shall behave altruistically towards the leader agent. And therefore, we define the optimum policy of this altruistic agent as the policy that maximizes the discounted future choice of the leader agent. So basically, the only objective of this agent is to find the policy that maxes the future choice that the leader agent has. And thereby, it shall act altruistically towards the leader agent. So we then kind of tested this initially in this very simple environment, which you've already seen before. So to this environment, we have added a door here, and we've also added a switch which operates this door. And then there's an apple, which is basically the target object of the leader agent. So the leader agent's policy will guide it towards this apple, and the altruistic agent will behave altruistically towards the leader agent without knowing that the objective of the leader agent is actually this apple. So we see here that we've replaced the agents by just colored squares now. We can see that just by maximizing the leader agent's choice, the altruistic agent has learned to use the switch to open the door here, thereby maximizing the choice of the leader agent, which enables the leader agent to forage the apple here. So let's make some changes to the environment here. So we've kind of removed the door and we've changed the position of the apple to up here, and we can see what happens next. We can see what happens here for a choice horizon of n equals 2. We can see that the leader agent will still just make its way through to the apple, and the altruistic agent kind of just stays in the corner to not impede the leader agents, to not be in the leader agent's way. There's one interesting case, though, that we observed here, and that is if we kind of define choice in a bad way given the circumstances of the environment. So, for example, what we did here now is we only looked at one-step choice, not a two-step choice, which means we estimate the choice as only the number of cells that the agent can reach within a one-step time horizon. And now the altruistic agent maximizes this metric. Then what will happen is the following. What we can see here is that the altruistic agent actually blocks the way of the leader agent, so it can't get through to the apple. Again, here the altruistic agent doesn't know that the goal is actually that the goal of the leader agent is actually the apple. But why does this happen? So as the altruistic agent has no objective of the leader agent, it maximizes the future choice of the leader agent by not letting it enter this tunnel, because this tunnel is basically a region of few choices. So what we can basically see here is that this is kind of a failure case if we purely maximize choice, is that the altruistic agent forcefully maximizes the choice that the leader agent has, and therefore it hinders it from entering this tunnel. What we've done next is we looked at kind of at more complex environments. So this is the simple tech environment. It's a very simple multi-agent cooperative environment where we have obstacles here in gray, and then we have 3 adversarial agents here in red, 1, 2, and 3, that try to catch a green leader agent. So what we have here is we just have these agents trying to catch it, and as they outnumber the leader agent, they will normally get them. And this is kind of the environment as it's given. So all these policies are pre-trained. And what we did is like now if we look at this environment, we can see that if the leader agent is chased by the 3 adversary agents, then it only has 8% relative choice. So it has very little choice because it can basically only go one way. Versus if the leader agent is in a position where it has many possible options, where the adversaries are far away, then it has 78% relative choice as computed by us. So it basically has many options of escaping or has a lot of freedom in its actions. So what we did then is we took this environment with the pre-trained adversaries and the leader agent, and we inserted 3 additional agents, which are these blue agents here. And these 3 additional agents are trained to act altruistically towards the leader agent. So these 3 agents are put into the environment, and they have learned a policy that maximizes the choice of the leader agent. And this is kind of what happens. So this is slowed down so you can see it a bit better. But basically what we can see here is that the altruistic agent have learned to actively shield the leader from its adversaries, and thereby they maximize its choice. Again, here they kind of like directly bump into the adversaries, or they try to bump into the adversaries, and they protect the leader agent from the adversaries just through maximizing the choice of the leader agent. Yeah, so this is a very fast forward presentation of this work, but kind of what are the main conclusions from our work and what are potential ideas of how this is related to the hackathon. Conclusions are maximizing the number of choices for others is one way of potentially behaving altruistically towards them, but then also hyperparameters and assumptions have to be taken into careful consideration kind of to prevent contrary outcomes. So likely maximizing choice of others has to be combined with other objectives. How is this related to the hackathon? Obviously, the obvious question is like kind of how can we relate choice of an agent to agency of an agent? And then also, so what we've done in this work is we have considered just one sampling policy for the agent. But if we considered arbitrary sampling policies to compute choice, then this would move us more from choice into the direction of empowerment, which is a very interesting concept which Catalin and I looked into, and which we think is very related, or probably even more related to agency. Here's also some useful resources. So at the top, here's our paper. Then there's the foundational paper on empowerment, which is also linked out on the hackathon website. And this is a paper on maximizing empowerment for intrinsically motivated reinforcement learning agents. So it's a single agent scenario here. What's basically done is we have an agent that maximizes its own empowerment and thereby explores the environment and learns many kind of useful things. Here are some environments which I think are very cool. There's this mini-grid environment, which is a single agent implementation of navigation environments, with one example shown over here on the right. Then is RL starter files, which is a GitHub repository that allows to train and evaluate agents immediately in mini-grid. And then there is the petting zoo framework, which is a collection of multi-agent environments. And they kind of have a unified framework for all environments, such as, or comparable to how OpenAI Gym implemented multiple single agent environments. Yep, that's everything from my side, and happy to answer any questions.
Wonderful, thank you so much, Tim. And people are again, of course, welcome to raise their hand, but let us give a little virtual hands to you as well. They're always good. One question I'm curious about, Tim, is how do you see this being developed, like this choice or entropy maximization for the leader agent, be transformed into a sort of agency maximization as well? And do you see, are there some clear ontological differences between the two that you have a hard time connecting?
So this was very interesting because Catalin came across our paper and he was like, this seems very related to agency. But then we both looked into kind of literature a bit more, and we think, okay, choice is one way, but choice is kind of a passive measure. So it doesn't capture how well you are able to actually pursue your goals. It's more like, I have all these things, but I don't know if I can actually pursue them. So I don't know if I have the ability to actually kind of like go for something. And this is why we think empowerment, which is kind of a similar framework, but not directly choice, empowerment might also be very interesting, because empowerment is basically a measure of both. So empowerment measures how much can I access, and can I access it in a controlled way.
Interesting.
And kind of like looking into this, I think we both kind of agreed that empowerment is probably the mathematical metric in literature, or definitely in RL literature, which we think right now seems to be most related to agency.
Interesting. And do you see some obvious solutions to the Apple tunnel problem?
I mean, the obvious solution, or the Apple tunnel problem, is, I guess this is like, we spun it all the way where we said we want to maximize choice.
Oh, all right. I think he might have hit a button or a microphone there. Well, I'll invite you up to chat as well, Kat, if you want to.
It looks like very interesting work, and I talked to both to both Tim and his supervisor a little bit about this. It's really great to see people have already pioneered some of this way of thinking about the world. Indeed, just option maximization doesn't really solve the problem. I actually wasn't aware of this last case scenario where if you only model one step into the future, you get this weird place where you're blocking the actual goals of the primary agent, which is very related to what I write about in this idea that AI systems that like are optimizing blindly for maybe safety or something else like that can really have very negative outcomes on individual human choice, right? I have this little sketch of a mouse that's in this little grid-like world, and then like it has all these options. Interacting with a mouse that might kill it, or exploring new or novel things. But if you have an AI system that's kind of guiding or modeling its behavior over time, that system could, in principle, just say, hey, you know something, to optimize for your safety in your future, we're just going to remove everything. We'll just feed you the safe kibble that mouse chow, or whatever you want to call it, dog chow, and you can just be happy forever. You'll survive forever, but you're just going to be eating mouse chow in your little corner. So it's obviously a caricature of what happens, but that's anyways, that's really cool. And I think Tim's also going to share maybe a little bit of his code and stuff. And I also will put some more things online about the IRL data sets.
Nice, that's wonderful. And I linked the paper if that has the code itself. I'm not sure, but wonderful. I think he might have fallen to the grace of our virtual overlords here. But if he is done, then let us appreciate his sacrifice until he's back.